Hi guys, welcome to other episode of MrLopezClasses.com. This is the chapter 3, episode number 1. This chapter is dedicated to classification of marine engines. Marine engines classification. We are going to start with a short review about the types of propulsion system. And we are going to use the first slides of the chapter 5 of your book of Introduction to Marine Engineering. We are going to use the first slide of the chapter 5 in order to refresh the types of propulsion system. This is important in order to understand how the diesel engines are classified. Alright, what is the classification of diesel engines? The diesel, not only diesel engines, the marine engines. The marine engines are classified into inboard engines, and outboard engines. And the inboard engines are electric motors, diesel, and gasoline. And the electric motors are divided in AC current and DC current. Yeah, and the diesel engines are classified into 2-stroke engines and 4-stroke engines. The majority of the inboard engines are 4 strokes for marine application. The majority of those engines are 4 strokes. In outboards, we have a 2-stroke and 4-stroke, diesel and gas. Both of them, diesel and gas. And electric motors for outboards normally DC motors, and some designs they have AC motors with power coming from inverters. We are going to study later what is the procedure. Alright, this is the classification of the marine engines, inboard and outboards, and we are going to check where are located the diesel engines in that big classification. Okay, my friends, now we are going to check the classification or the definition of an inboard engine. I repeat again and again in different videos that the inboard engines, the marine inboard engines, are automotive engines adapted to work in a boat. What is the adaptation? What type of change you need in an automotive car in order to work in a boat? It's simple. The only that you need replaced is the cooling systems. The cooling system. In your boat, it's too simple. Can I replace the engine in my boat for an automotive engine? Yes. It's too simple. The only that you need is the engine that you have in your car. The coolant is refrigerated for the radiator, like the picture that you have on the screen right now. The coolant internally in the block and the head pass through the radiator, and the radiator cool the coolant, decrease the temperature, and the coolant return into the engine with low temperature. What happened in the radiator? The radiator have a fan, and the fan circulate the air through the serpentine of the radiator, and the coolant decrease the temperature. When the coolant enter into the engine on the thermostat housing, the coolant enter with low temperature and refrigerate again the engine and return into the radiator, and the cycle continue because the engine have a coolant pump or circulating pump or freshwater pump dedicated to circulate the coolant through the engine and the radiator and return, the engine and the radiator and return. This is the cycle of refrigeration that we are going to study later in other chapter. This is the car, this is the engine in your car. In your boat, it's pretty simple. You only replace the radiator for a heat exchanger. You replace that radiator for a heat exchanger, and now the coolant pass through the heat exchanger internally. You see the serpentine is the same, but in the heat exchanger you have salt water. The salt water pass through the heat exchanger, and the salt water goes in the other side, enter in the exhaust manifold of the engine, and bye-bye. Yes, you can replace the engine of your boat for any automotive engine. The only that you need take in consideration is the cooling system, the refrigeration system. In your boat, the coolant is refrigerated for salt water by means of a heat exchanger. In your car, the coolant is refrigerated for the radiator. The radiator with the fan in front of the radiator decrease the temperature of the coolant and the coolant return into the engine. This is the process. Yeah, but in general, the inboard engines, gas or diesel, they are automotive engines adapted to work in the boat. For that reason, if you in the next coming videos, we are going to check different diesel engines, and the majority of the diesel engines that you founded in the boats are engines that are commonly used in trucks, in bus, in agricultural equipment, in generators. The same engine is used in millions of applications. The same engine, gas or diesel, is used in different applications. And there are engines with a high reputation because those engines are excellent in agricultural application, excellent in transportation, excellent in boats. Cummins have great examples: Caterpillar, Detroit Diesel, Mack, Yanmar. There are a lot of manufacturers that they have great products, and those products, you founded those products in different applications. I am going to explain later that you can use the same engine in your boat. You need to change the cooling system, and also you need to calibrate the fuel injection pump in order to work at low RPMs in wide open throttle. You remember what is normally the wide open throttle for diesel engines inboard? Is around 2500. Okay, and how much is the wide open throttle for the same engine when the engine is on the truck? 6,000 RPMs, 5,000. For that reason, you need to calibrate the fuel injection pump. But we are going to study later about that. But the engine is the same. The engine is exactly the same. The only difference is the cooling system and the exhaust manifold, because we need to replace the exhaust manifold to receive the water at the end and send the water with gases outside. That's too simple. This is not complicated. I am going to explain the procedure step by step in order to repower the boat from gasoline into diesel, and in order to convert the boat now to diesel engine. There are a lot of tips that I am going to get to use to do that project. This course is a wonderful course for marine engineers, for marine technicians, and this is a course that the majority of the people love it, because it's a great complement to take the ABYC certification, and it's a great complement to start to work in this fascinating world, the world of diesel. I have a lot of students that I passed for my class, and right now they are successful engineers in great companies like Caterpillar, Detroit Diesel. A lot of companies have my students working in great positions. All right. Okay, now we are going to continue with the definition of inboard engines. An inboard engine is a 4-stroke automotive engine, gas or diesel, adapted for marine application. The inboard engines normally are mounted inside of the hull, and normally in the middle or in front of the transom. Yeah, the engine turns and drives the shaft that runs through the bottom of the hull and is attached to the propeller in the other end. Right now we are going to talk about that, and we are going to check the different type of propulsion systems. All right, the steering in the majority of the inboard vessels, except in PWC, right now we are going to talk about that, and except in jet drives, is controlled by the rudder. For that reason, I introduce the chapter 5 of your intro marine engineering book in order to refresh quickly the propulsion system, and we are going to pass quickly about those types of propulsion systems. All right, my friends, we are going to start quickly with the inboard engines. The outboard engines. the outboard engines are divided in three sections. The first section is the power head, is where the engine is located, gas or diesel. Yeah, every day are more diesel outboards. Every day, when you visit the boat show, you found that every year in the stand of outboards, more diesel engines. Yeah, smaller, not too heavy. That was the inconvenience some years ago. Today, no. And properly refrigerated. And there are diesel engines with radiator, no refrigerated for salt water. Right now, we are going to talk about that. The middle section, the section or mid-section, is the exhaust housing. In this area, the exhaust is located in order to bring the gases here, and outside you have water and gases. All right, and in the bottom or lower unit, you have the gearbox or transmissions. Yes, the outboards are divided in power head on top, midsection or exhaust, and lower unit or gearbox. Don't forget, the power head is the engine, power, the middle section is the exhaust, and the lower unit is the transmission or gearbox. Okay, those are the most common types of drive systems. And in this picture is necessary included two additional that we are going to explain right now. This is the most common, the drive system, the first one. The engine is basically located in the middle section of the boat, and the shaft and the propeller are under the hull of the boat. This is good because the center of gravity of the boat is approximated in the center of the boat, and the stability of the boat is excellent, and the performance of the boat is good. This is the only inconvenience with the number one is that it's located in the middle of the boat. In some cases, that design is not good for other factors. For example, the second one, the number two, the V drive, is excellent. Because the engine is located pretty close to the transom of the boat. In other words, the number one and the number two, the V drive, is used when the design have smaller areas on the engine room. That's the reason why the people use this design or this one instead of the first one. All right, what is the difference between the first one and the second one? In the first one, the front of the engine is facing forward to the bow. In this one, the front of the engine is facing aft to the transom. The engine is opposite. Yeah, and in this one, the transmission is a V-drive transmission. It's a transmission with a V angle, with this angle. All right, in this transmission, the transmission is a straight transmission. This is the next course that I want that you enjoy, transmissions. All right. And the advantage of the second one in comparison with the first one is basically the location of the engine, and is used for engine rooms with short space, with short room. The number three is excellent, is the steam drive or inboard outboard, because this is the combination inboard outboard. The other name for the steam drive system is in-out, inboard outboard. Yes, this system is wonderful for high performance. For that reason, if you check the majority of the race boats, they have that combination, the combination of the outboard lower unit with the big inboard engine. Exactly, this is the advantage of that system. You remember in this one, how much are normally the RPMs in a typical, the wide open throttle in a typical outboard engine, outboard? It's around 5,000, 6,000 RPMs, no? It's a lot of RPMs. Okay, and you remember how much are the typical wide open throttle in an inboard engine? Is around 2,500, no? Diesel, 2,500. what happens if I combine a big engine inboard with a lower unit? Oh, I have a big engine, 7 liters or 6.8 liters or bigger than this, diesel with an outboard, and I have an excellent combination. I have higher RPMs outboard with a big muscle engine inside. This is a great combination, no? Excellent combination. Why can I have higher RPMs with the outboard? Because it's outboard. Because the propeller is not under the boat. That's the difference. What happens if the propeller is in the bottom, below the hull? Is possible to reach that amount of RPMs, more than 1500 RPMs? Probably no, because you introduce excessive vibration and you can destroy the hull. If the propeller is outside of the boat, I can increase the RPM unlimited, and I don't destroy the hull. For that reason, we are going to talk in the next one about the surface drive. The surface drive, the propeller is outside, and you don't have limits in diameter of propeller. You don't have limits in number of blades. You don't have limits in RPMs, because the propeller is outside and you don't destroy the hull. When the propeller is here, behind of the hull, you introduce a lot of vibration, and it's possible to destroy the hull. Yeah, this is the main difference. This is the typical boat inboard with the propeller and the shaft behind of the hull, and in front of the propeller you have the rudder. You have the rudder here. That's the rudder in front of the propeller in order to steer the boat in one direction or other direction. This is the typical. Here you have a diesel or gasoline engines, the transmission, the shaft, and the propeller. The typical direct drive system with inboard engine, diesel or gas, exactly the same. Alright, this is the typical other picture, a lateral picture about the inboard engine. That's the engine, the transmission, the shaft, the propeller, and the rudder, everything behind of the hull. Alright? What is the limitation? The limitation is the RPMs of the propeller and the RPMs of the engine. Okay, if the engine is rotating at 2200 RPMs wide open throttle, and the gear ratio of the transmission is 2:1, we are going to talk later about that. If the gear ratio is 2:1, you remember in intro, how much are the RPMs of the propeller? 1100, because the gear ratio is 2:1. Yeah, that's the typical inboard engine. And the transmission, this is the engine, this is the engine, this is the transmission, this is the input shaft of the transmission, and this is the output shaft of the transmission. And in this particular example, the gear ratio is 2:1. Yeah, typical is an inboard. The inboard engine, once again, is an automotive engine adapted to work in a boat. Yeah, you convert the exhaust manifold and the refrigeration system, and you use exactly the same engine for an inboard application. This is the same picture. And this is the V drive. This is the V drive. In this picture, the engine is facing forward. This is the bow, and this is the stern. In this design, in the V drive, the engine is facing aft into the transom, and the transmission is a V angle. For that reason, it's V drive. Look, this is the angle of the transmission. It's a V. This is the angle. For that reason, you call this system a V drive configuration. But it's basically the same. You have the propeller under the hull. You have the propeller here and the rudder. It's exactly the same like this system with the this system with the propeller and the rudder behind of the hull. Yeah, it's exactly the same. The performance is similar. The only advantage is that if you have a small engine room with a small area, with a small distance, this design is better, because the other one with the engine here, you need to locate the engine in the middle of the boat. Yeah, in this design, you pass the engine up, and for a small engine rooms application. Is clear the explanation, my friends? All right, thank you. Thank you very much. There are different configurations in order to create the V-drive transmission. Look at the V-drive transmission. And we are going to talk later about that situation. This is the other schematic of the V-drive. This is a good schematic about the V-drive configuration. All right, the other system is the steam drive configuration. The steam drive configuration, like I explained before, the engine is pretty close to the transom, is against the transom, and the outboard immediately outside after the transom. This is a perfect design for race performance, for race boats. Why? Because you can combine the best scenario of the outboards, good lower unit for high RPMs, and the inboard situation for a big engine, gas or diesel with too much horsepower, with too much torque. Yeah, this is for example, this is a typical Volvo diesel engine at the inboard, and the outboard is a special lower unit, normally with double propeller, double thrust, in order to support the amount of torque produced for the diesel engine. Yes, not all the lower units, not all the typical lower units are good for a diesel inboard engine. You need to verify if the lower unit accept that amount of torque produced for the diesel engine. In the moment that you want to repower a boat, replacing the gasoline engine for diesel, you need, and of course, if you want to use the same transmission, you need to verify if the transmission is enough to support the amount of torque and horsepower produced for the diesel engine. This is a critical, and you need to pay attention in that factor, the factor of the torque. Okay, this is exactly the same. The transom is located here. This is the lower unit, and this is the inboard engine, the typical configuration. All right, and other common equipment that we are going to use is the surface drive. The surface drive is excellent because the propeller is completely outside of the boat. If you check here in this example, this is the transom. Inside of the transom you have the transmission and the engine. Yeah, this is the engine. The engine is located here. The transmission is here, and this is the surface drive outside. Yes, you have a 1, 2, or like this with 4 engines, 1, 2, 3, and 4 engines, or this one with 3 engines. Excellent design. What is the advantage? You can put outside. You remember in our course of intro, in a typical inboard boat with inboard propeller, what is the amount of blades normally for those boats? Normally it's 3 or 4, maximum 5 in some designs, but no more than 5, because you produce overlap, you remember? But if I have the propeller outside of the boat, can I put more than 5 blades? Yes. For example, look at this propeller. It's 1, 2, 3, 4, 5, 6 blades, and you have 3 propellers with 6 blades. What happens if you have 3 propellers with 6 blades under the boat? You destroy the boat easily. If you have 3 propellers with 6 blades or 7 blades outside of the boat, no problem. Ultra high speed for high performance. The surface drive is excellent for high performance boats, race boats. You need to be careful in the design, because you have propellers outside spinning at high speed. For that reason, in recreational boats, fishing boats, family boats, that design, you need to be careful. Normally the people cover the propeller with the swim platform, like this. In this design, the swim platform cover the propeller in order to protect the boat. And the swim platform is adjustable. At high speed you can move it, the swim platform, and the propellers are open to the space. This is one of the advantages of that design. Look, this is another picture about this design. Yeah, the transom is here, and the system, the surface drive system is located outside. Harness on drive is one manufacturer, is famous because the quality of the system. Harness on is an excellent design, or Hamilton is another one. Those are external surface drive design with an excellent performance. Yeah, this is another good picture. This is inside of the boat. This is the transmission. The transmission is located here. This is the transom, and this is outside of the boat. Outside of the boat we have the jet drive system, and inside we have the transmission and the system. All the elements located outside, if you check, are actuators, cylinders, actuators, other actuators. Those actuators internally are controlled for servo hydraulic systems, power units. You remember in our course of electronics when I explained to you the servo unit and the power assisted unit, hydraulic unit, those are the units. And we are going to use the same units, similar units, in order to, look, this one is to control one cylinder or a couple of cylinders, and the other one to control other couple of cylinders, because the jet drive have two actuators to control up and down, and other two actuators to control lateral movement. And the propeller is outside of the boat. Yes, internally, those hydraulic systems are located in the transom, and those hydraulic units are controlled by the joystick. The joystick with your hands, like the joystick that you have in your picture right now, control up and down, and left and right. All right, you like it? This is an excellent design. This is the surface drive design. I explained those designs with a little more details in our course of intro, and we are going to talk later again in our course of auxiliary systems. In the course of auxiliary system, I am going to explain the procedure to connect those hydraulic units with the cylinders, and the procedure to create the controls for those units. That's a wonderful course. I hope you enjoy that course. Visit my webpage and check the book of auxiliary system and the episodes related with the hydraulic units. Alright, my friends, and this is the harness on surface drive. Have too much advantage in comparison with the rest of the system, the system that we studied previously, the inboard, the V drive, the steam drive. This system is positive thrust steering, superior maneuverability. The maintenance is simple, is less parts in constant movement, low maintenance. Is a greater flexibility for engine replacement, that's true, and less vibration because the propeller is located outside. The propeller no produce vibration because it's outside. And other design that, in my opinion, is the top of the designs is this one. The inboard performance system is this one that you have on the screen right now. Is a great combination of inboard diesel engines, in this particular case Volvo, this design is Volvo, it's a Volvo design, inboard diesel engines with that lower unit located behind of the boat, under the boat, with the advantage that that system rotates 360 degrees. Wonderful. You rotate that system 360. With this design, you move the boat forward, reverse, and lateral. You don't need bow thruster. You don't need a steam thruster. This is a wonderful design. Look at this. Behind of the boat, under the boat, you have this picture. That's the picture behind of the boat, and those are the units, and the units rotate 360 degrees. There are a lot of boats with this design. The propeller position is well under the hull, giving minimum risk of cavitation caused by the air intrusion when you have the propellers outside. That's true. This is a wonderful design. This is the Volvo Penta IPS 500. Yeah, and the propellers are forward face. You see, because this is normally the transom of the boat, and this is the transom. The propellers are in opposite direction, but this is a great design. I love that design. This is a design that every year they advance with more sophistication, and the control for this system is the joystick that you have on the screen. It's too simple. It's very nice. The console of the boat looks organized with that system. It's a wonderful system. Yeah, this is another view of the iPod system inside of the boat. That's nice. And there are a lot of advantages of that system. Improved efficiency, are higher top speed, reduce fuel consumption, good maneuverability, excellent speed. The service is simple. There are a lot of advantages of that system in comparison with the other ones. I love this system. This system is safe, is accurate, and is a great innovation. I love it. And you can, in the future, when we talk about the hybrid boats, you can replace the big diesel engine inside. You can replace the big diesel engine for an electric motor. Look at this design. You can replace the electrical IPS. You can replace the diesel engine for an electric motor, and you can convert your boat into hybrid iPod. And look, this is the clutch in order to engage or disengage the electric motor. We are going to talk later about that. This is another wonderful design. This is the manufacturer. You can check online and verify the advantage of those systems. All right, and now we are going to talk about other wonderful system. Is the jet drive. The jet drive configuration, that one. It's a wonderful system. It's basically a pump that compresses the water, and when the water is full compressed, pass through the funnel, and the funnel produces reaction, and the boat moves in the opposite of the jet of water. That's too simple. And yes, internally you can move the jet drive unit. This is the jet drive unit. This is the unit, and this is the power. The power could be with a diesel engine or with a gas engine. Both of them work perfect for that design. And this is the jet drive. The jet drive have an engine internally. The engine is mounted inside of the boat and attached to the high-speed pumps. We draw the water through the intake and increase the velocity and force through the directional adjustable nozzle. Let me explain. I have another good picture about this. This is the jet drive. The jet drive draws the water from under the boat through an intake and into a pump jet or impeller jet, and force the water to pass through the funnel. And when the water passes through the funnel, this funnel here produce the reaction. The boat moves in one direction and the jet of water in the other direction. It's too simple. And the shaft of this pump is connected with a coupling with the engine. Yeah, exactly. This is the nozzle. This is the jet drive. This is the jet drive configuration. This is the coupling, and you can replace internally here the motor for an electric motor. You can connect, instead of the diesel or gasoline motor, you can connect a generator. An AC motor for high torque and high speed. And the AC motor, you have two options. You can receive the power from a generator, or you can receive the power from a big inverter. And the inverter connected with batteries, and the batteries received from the solar panel system. This is the hybrid boat that we are going to talk later. Yes, this is the jet drive configuration. Look, the water enters in the bottom, and internally the blades of the pump compress the water and after that pass through the funnel, the triangle here, and produce the reaction, the boat in this direction, high speed, and other jet of water in the opposite direction at high speed. You remember the third law of Newton, high speed. All right, those are the most common propulsion systems. And now, with that information, we are going to continue to start with diesel engines and understand how the diesel engines can be installed in those different types of propulsion systems.